All right, happy Thursday. How's everyone doing?
Good.
Love that. Have I told you I had a baby this summer? She loves to hang out in the windowsill. This was last week, just adorable. So we have a medium-sized one today. We just got through mini exam 1. Hopefully you feel good about how that went. If you ever don't feel good about how things went, I'd love to sit down and talk to you. Like I mentioned, at the beginning of the semester and before the mini exams, my intention with this class is to give you all the resources you want, to be very clear about what I expect from you, and then to make sure that you can hit whatever level of preparation you're hoping for. That's my goal in this class. So the outlook for the next 2 weeks, we have part 1, we're starting today. So we're going to talk about numerical relationships between variables. Then next week, we're going to talk about numerical and categorical data. So how do we summarize numerical categorical relationships? And then we'll talk about numerical, and categorical. So this is multivariate, so trivariate data. And then we're going to take our second mini exam 2 weeks from yesterday, or 2 weeks from Tuesday. So we have 3 more topics to cover, and then we're going to get to our next mini exam. There'll be a little more roughly every 2 weeks for the next few parts. All right, so that's where we're going. Are there any questions? We might have some time at the end of class. I would love to talk to you all about your questions about the Part 1 project. I also have office hours tomorrow, so 10:30 to 12:30. And that's a great time to just drop in and talk about the projects. For the Part 2 project, we're actually going to have a project workshop where we sit down and sort of have a more structured conversation about the projects. For this one, you all, I think, are pretty familiar with the types of things we're doing. So the main thing is just getting familiar with working with data sets. Some of you are working with data sets hosted in your own Google Drive account. I've given you some guidance on how to get that set up. We're going to talk more about that with the Part 2 project. But feel free to start exploring that as you like. There's guidance in the project template right here. So if you want to do that, I walk you through a little bit how to do that here. Okay, and then so that's due on Friday. As always, if you need an extension, just let me know through Sunday night. And then I just posted homework 2.1, so that's based on what we're doing today. Again, this shouldn't really take that much time. We break the homeworks up into nice, tiny little chunks, so none of them feel that challenging all at once. Okay, any other questions? Housekeeping? So far this semester, we've talked about summarizing single variables. We've gone a little bit outside of the core single variable types of questions when we think about panel data, right? Like panels almost multiple variables. When we think about like an entity index, sometimes we can think of this as a categorical variable. But primarily we focused on single variable applications. So summarizing single variables. You'll remember we started the semester thinking about what we were trying to do this semester, right? Like we are in the field, are economists. We think about decision making using models, and then we go out into the world and we try to test our models using data. This is what we do in every area of science. We can have the best ideas in the world, but if they don't validate our data, if our data doesn't validate our models are nearly meaningless. So that's what we're trying to do. We're trying to understand behavior and decision making using real data. So what we've done so far is focus on single variables. And this is helpful in some contexts, right? Like you can think about distributions of variables. But if you had this growing sense that thinking about single variables wasn't really the end to what we're doing, you're in the right place. Usually when we build a model, we have multiple variables of interest. So the first thing I want to do is just show you 4 different data sets. And you're going to get your hands on this data. This is a very famous quartet of data sets. We're actually going to work with this in a notebook in a second. But I just want to show you some summary statistics of these variables. We've talked about mean and standard deviation. Each one of these data sets has, so these are the 4 different data sets, each in their own row, and I'm giving you summary statistics for all 4. Both data sets contain numerical, 2 numerical variables, an x and a y. And I've just listed the summary statistics for these 4 data sets. So I have the mean here, so the mean of x for data set 1 is 9. So it's just a number, and I'm giving you the mean. The mean of y, so our second variable in data set 1 is 7.5. And then I have the standard deviation, so the sort of the average variability for both x and y. So I have a standard deviation of 3.32 in the first data set for x. And then for y in the first data set, the standard deviation is 2.03. And then because this is 2 variables, I'm also listing, you all are familiar with correlation. So this is just essentially like a standardized way of measuring how closely related 2 variables are to each other. And I have a correlation of 0.82 between x and y in the first data set. So my question, we have 4 data sets, and I'm giving you the summary statistics for x and y in all 4 of the data sets. This is one approach to summarizing data, particularly bivariate data, introducing this measure of the correlation between the 2 variables. And what you can see here is we have the same means, same standard deviations, and same correlations between both the x and the y variable in each one of the 4 data sets. So what we're going to do, I want to ask you a question, which is essentially, are the relationships between x and y the same in all 4 of these data sets? We have 4 data sets. All the summary statistics are the same. Are the relationships between x and y the same in each one of these 4 data sets? I want you to spend like 10 seconds, maybe 20 seconds just pondering this. Tell your neighbor something fun you're going to do this weekend. Unfortunately, we don't have a Super Bowl going on, so it's not quite as maybe exciting. What's something fun you're going to do this weekend instead? And then, do you think these are the same, these 4?
I don't know. I think the data sets could be comparing different things. Like different, like actual categories. Maybe they just have this. Where are you guys? Yeah, where?
Okay, someone help me out here. I'd love to hear about the fun things they're doing this weekend, but maybe to stay on track or on topic. How many of you think these data sets are the same? How many of you think the data sets are not the same? Yeah, it's like, why am I asking this question if they're the same? So, but why do you think they're different? Someone want to help me out here? Yeah.
They could all theoretically have like different data in it, even though they have the same mean, standard deviation, whatever. They could have different numbers.
So, so like they're representing different things.
Well, like data set one, like I mean, I couldn't do the math in my head, but it could be like a string of numbers that have a mean of 9, whatever. I guess if that makes sense.
Yeah.
Like the underlying data could be different. I guess what you're saying.
Yeah. So even though like the center is the same, maybe they're like distributed differently.
Kind of. I mean, standard deviation is the same too.
Yeah. The spread is the same. The middle is the same. Yeah. Is it Matt?
Brad.
Brad. I'm sorry. Yeah. So maybe like X represents a different like measure, even though the numbers are the same. Maybe it's representing a different thing. Yeah. So that definitely could be true. Remind me of your name, Kim. So Kim is saying maybe these are representing different things. If I were to change this question slightly, so this is totally true. These could be representing different things. They give the same summary statistics. If I were to ask this question maybe slightly differently, do these data sets have the same numbers in them? Are they representing the same relationships? I see a couple people shaking your head no. Why do you think no? And me asking this question isn't enough of a justification. Yeah, Pete? Yeah.
They could not as well.
Yeah, so maybe the patterns are different, and simply because we're summarizing these in these like summary statistics, these 5 numbers, maybe it's obscuring something else that's going on underneath. Yeah, this is a very data visualization answer to this question. Do you all want to take a look at these data sets? This is a very famous data set. These are 4 famous data sets. This is what we call Anscombe's quartet. And I've loaded this in the exercise 2.1 notebook. So you can just click on this. Oh, that's not what it's supposed to do. Hold on just a second. Can you continue telling each other something fun you're going to do this weekend? Give me 1 second. I'm going to fix this problem.
Yeah, but I didn't realize, like, because I'm from DC, but like, I feel like I never have to book a restaurant or rest that much, but here it was like, I'm from, like, Tennessee. Yeah. Yeah, and then like all the places, a lot of the nice places, they were already like full for thousands.
Dude, a lot of these places get booked like 6 months in advance.
Yeah, and there's like the only ones that open to us are like 10 p.m. slots, and I'm like, I'm not gonna do that.
It's like so convenient.
Yeah. It's the thought that counts.
Yeah, right.
You have the same problem too when you click on it.
I have a champagne chef this morning on Friday. So last night, and it's also like a rhyme with that reason. It's like the they'd be like night Italian, like a super I slept with one of my thousand. So
And is this with like your parents?
yeah.
What's a fun?
Yeah, we're gonna be together with a bottle of champagne.
Yeah.
Yeah, but it's like each parent gets like 2 bottles. We get like half of one then, so I gotta be.
Who's gonna carry them? You got levels. Who's gonna carry them notes? Yeah.
I have 3 exams next week. It's gonna be great.
Oh man.
Something like that. So,
What mic?
it's my birthday.
But is it an intermediate or
No, just
the first one? I'm taking intermediate macro. I took macro. Yeah, because it's more like the theory. So.
Policy
Yeah.
intermediate lecture.
Is it hard for you? It was hard for me. It's like the hardest class I've taken.
That's what I know.
All right, sorry about that. So the website's still updating. I posted the link to the exercise on Canvas, so you can hop on over there.
I feel like it's I was
So you can find the exercise here. So I'm going to click on this. Sorry you have to sign into your PIT account. Isn't it so nice? Normally we don't have to do that. Okay, so we're just going to walk through the first data set. So this is what we call Anscombe's quartet. I'm just going to load everything, our imports. Actually, what did I skip? What was the thing I forgot to do at the beginning?
save it to your drive.
Save it to my drive. Okay, so I'm going to go up here, File, Save a copy in Drive, and that creates a copy for me. Okay, so I'm going to load all the packages. I'm going to find the file path where the data is, and then I'm going to load the data set itself. This is so famous of a data set that Seaborn actually has it built in. So this is what it looks like. If we create summary statistics using the cell I just gave you, we can just print out the summary statistics for each of the data sets. So we have a column representing each one of the data sets, and then this is just some fancy little code to print out a summary table by data set. You don't need to know how to write this. I'm just giving this to you just to get the summary statistics.
Do you have any advice for if you're clicking the notebook, it doesn't go to over like Python, it just has a black screen with all the code in the list?
It does that on the course website. If you go to Canvas, that has a good link. Yeah. Yeah, any other questions? Okay, so I want to, I'm asking this question of you. If you remember, before the brief interruption, I asked, are these data sets the same? How might we go about trying to think about the answer to this question? Are these data sets the same? Are they representing the same relationships between data? We thought the answer was no, but how do we know? One, no idea. Anyone have ideas here? This semester, particularly at the end of part 2, when you do your part 2 project, you're going to be encountering a similar kind of question. You want to know what the relationship is between two variables. And you want to know what the shape of that relationship is. You can give me summary statistics, like the mean for each variable, the distribution, or the variability, and the correlation. But what I want to see is not just the summary statistics, but the actual sort of shape of the relationship. The way I would approach this is by constructing a scatter plot. We've talked about scatter plots, which allow us to show relationships between two numerical variables. But what I would do for this is to construct a scatter plot for each one of the 4 data sets. Here's a bit of some code to construct we've worked with rel plot before. Let's just copy this over and I'll talk you through what we're doing. This is rel plot, which is at base it's a scatter plot, but we can then break it up by a category. In this case, we want 4 different columns based on which one of the data sets we're looking at. So we're giving it the Anscombe data set. We have x for the x variable and y for the y variable. And then we have column for the data set. So each one of the data sets is going to have its own scatter plot. Let's take maybe 30 seconds to a minute here. I want you to run this, find out what the figure looks like, and then tell your neighbor whether the data sets are representing the same things. This code is in the slides if you get stuck.
It's just because we didn't
Okay, how many of you got a nice figure for this? Working on it? Someone want to tell me, are these the same data set? What's going on here? Let me run this. So this is in the notebook, but I have a better picture of it in the slides. So let me just show this to you. These are the 4 data sets. These are nothing alike. Same mean, same standard deviation, and same correlation between the x and the y variables. But the underlying relationship is entirely different. We have 4 entirely different relationships. If I were just summarizing these variables in the way I did, I would completely miss the fact that these are just entirely different data sets themselves. Okay, this is about the end of this point, right? We've talked a lot about data visualization. This is just to highlight, when we look at data, we want to visualize it to understand what's going on. Our eyes are just much better at understanding data visually than by looking at a table. And when we look at like summary statistics, the summary statistics will fundamentally miss a lot of what's going on in the data. This is one of the best examples. It's so famous because it highlights this point really clearly. Anscombe's quartet. These are not the same data. Very, very different. Okay, so what we're doing in part 1.2 is looking at primarily bivariate numerical relationships. We're also going to look at trivariate, so when we have 3 numerical variables that we're interested in. It's a little bit harder to do, but I'll show you some tricks to do it. But that's essentially what we're doing in part 2, is exploring relationships between variables, and primarily visually because it's really our best tool for understanding data. Okay, so we're going to work with this data set. This is, I have data on GDP by country and coffee production by country. Lots of countries import coffee. There are only a few countries that do a lot of exporting of coffee. So these are the countries that are primarily producing coffee for export. We'll talk through some of the examples of these countries in a second. What about this question? Is there a relationship between GDP and copy production? Did I burn you out with a mini exam? Y'all doing good? What do you think of this question? Yeah, Zach.
I think it's like you could make a claim that there's a relationship, but maybe not necessarily a direct correlation. Like,
Okay.
yeah, like maybe coffee production represents a good percentage of GDP, but from the data you can't like tell exactly how much that is.
Okay. So yeah, maybe we can't really tell. This is the way we've summarized numerical variables so far. Until Anscombe's quartet. This separate distributions of numerical variables can tell us the distributions themselves, which can be useful. But exactly, there may be a relationship here. It's just we can't see with two separate distributions. In the same way, summary statistics can't show us the distributions themselves. One thing we've done is set everything up on a two-dimensional axis. Do y'all like this figure? I've taken each one of the countries, plotted them on the two-dimensional plane, and then just drawn a line through them. Do y'all like this? Why not? What's the theoretical reason why this is wrong? Yeah, Devin?
It's just kind of confusing to look at, and you kind of don't know what you're looking at and like what the data is supposed to be.
Yeah, so sort of just visually something feels off about this. Anyone know kind of why this is like theoretically wrong? Yeah, Mairead?
It doesn't seem like the fields are supposed to be connected because they're separate entities.
Exactly. We have separate entities, and by drawing a line through them, we're sort of indicating that this is one entity, which isn't correct. Like, we actually have many separate entities, and so we represent them with different visual objects. So what do? Yeah, Pete? Scatter plot. Let's make a scatter plot. Same data, but better visualization tool. All right, so we talked about scatter plots in the context of panel data. We just talked about scatter plots in the context of Anscombe's quartet. And this is just a third emphasis. When we have two dimensions of numerical data, the scatter plot is just an incredibly powerful tool for answering these kinds of questions. So is there a relationship between GDP and copy production, if you were looking at this? Lots of maybes, I see. I can read minds. I haven't told you that, but I'm a professional mind reader. Otherwise known as a dad. No, I can't read minds, unfortunately. So a scatter plot is really the right tool for this. We have two dimensions of numerical data. We're going to talk through specifically how to read scatter plots and then some modifications we can make to this example specifically that can make it more readable, right? Like when you're looking at this, you're thinking, I'm not quite sure if there's a relationship here. And we're going to actually make it easier to understand these kinds of relationships. Okay, so first question for you as we go through understanding the data visually. Which countries have a GDP above $2 trillion? So we'll take like 20 seconds here. I want you to not just answer the question, but find a process for how you would answer. And then I'll ask you for it. Tell your neighbor.
Yeah, you
A lot of stars.
seem interested.
Yeah.
Okay, someone want to help me out here? How do we find the countries that are above 2 trillion in GDP? Yeah.
Find 2 trillion x-axis, draw a line up from there.
So we find 2 trillion on the horizontal axis, then draw a vertical line, and then just find everything to the one side. Yeah, really nice. What about, so it turns out to be 3 countries. What about countries that have a production above 1/2 billion kilograms in total? How would we find that? Yeah.
It's a lot harder to do. You'd have to visualize the line between 2 and 1, like as halfway point. 2, it's easy because there's already a line there.
Yeah. So with 2 trillion, we had a grid line there. With 1/2 billion kilograms, we actually have to, construct one visually, right about here, and then we draw a horizontal line, and then just find all the countries that have a production above that line, which would look something like this. So when we're interpreting these figures, we use the axes to just tell us the scales. What about this one? Which countries produce less coffee per dollar than Brazil? So here's Brazil. Maybe spend 30 seconds here. There's a process. How would we find the answer to this question? Tell your neighbor, and then I'll ask you. You can.
You can. We have the ones that you go on the far bottom right. Yeah. Yeah. The best way to visualize it, we got a knot in the tail, so there's like a line from Brazil going up to if they're below Brazil, the ratio is
Yeah. The rectangle actually also works. But this is sort of the same approach. Someone want to tell me? I got some good answers from the front. How do we, maybe looking for someone else, how do we go about visualizing or answering this question with the data? What's the process? Yeah.
Create a line of Brazil's journey,
Okay.
show the slope and anything under it.
And you're saying connect a point at Brazil to the origin. So we're going to draw a line between Brazil and the origin, and then we're going to find which countries produce less coffee per dollar than Brazil. So we want to be lower on the vertical axis. I'm sorry, lower on the horizontal axis for a given production. So it's everything below the line would produce less coffee per dollar, or more GDP per production than Brazil. Yeah, lots of good answers. Any questions here? So we can use these separating lines to make comparisons between ratios. We can, also select all the countries that are higher production per dollar than Brazil above this line. And then one question I might ask is, do the GDPs of the upper or lower pair? I don't have. You're gonna have to give me 10 lecture points because I forgot to annotate a couple of pairs here. So what we're gonna do, unfortunately, the annotation is off. So I'm gonna update these slides and then post them later. But when we're thinking about comparing between countries, we can make, if I'm asking questions like this, do the GDPs of any two countries differ by a larger amount? I can highlight two different countries and then find the difference on the horizontal axis, which represents the difference in GDP for the two countries. And then I can just figure out which of the two GDP differences is larger. Unfortunately, I have this visualized, but for some reason it's not in the slides. So the second kind of question we can ask is whether the GDPs of any two pairs differ by more. And I don't have it here, but I do have the four countries visualized on the log scale. So all I've done with this figure is show, I've converted a linear scale, so on the horizontal axis I have just GDP measured in trillions, to a log scale. And this allows us to visualize ratios much more clearly, which is actually also going to matter when we think about making some kinds of relationships easier to understand, a lot like you'll see in your homework. But what I've done here with the log scale is every time I increase by one tick mark on the horizontal axis, I'm actually multiplying by 10. So I go from one tick mark, 0.01, to 0.001 to 0.001. I'm multiplying by 10. And what this does, this log scale, is allow me to make ratio comparisons more easily. On the linear scale, we could find the difference between any two countries, and that would tell us, visually on the horizontal axis, which difference is larger. With a log scale, because every time we're increasing by one tick mark, we're multiplying by some amount. In this case, it's 10. We can actually find ratios of any two countries, which in some cases is really powerful. So in this case, you can see Cameroon and Malawi are less than 10 units apart. So this is, just slightly over 1/2. Where Brazil and Thailand are a lot closer on the horizontal axis. So the ratio, you can see we're not increasing by as much going from Thailand to Brazil as we are from Malawi to Cameroon. So this is, somewhat useful. This is one of the reasons we like log scales, is we can make sort of ratio comparisons. But we can also use this property of logs. I'm going to skip through some of this because the figures are a little out of place. But we could ask these kinds of questions with logs. So which country produces the second highest amount of coffee? But all I'm doing here is just adding a log scale to both axes. And what this does, the big punchline, if I were to have correctly labeled all these figures, is sometimes it's easier to understand relationships when we're in log scales. If you go back to the original figure here, I asked you, is there a relationship between coffee production and GDP? And you said maybe, right? When you're looking at this figure, the answer is maybe. Very hard to tell. We've correctly visualized all of the data. But the answer is hard to tell because a lot of the data is clumped up around these small values. Fundamentally, what's going on with your eyes is that you can't separate out what's going on in the differences between these small values. When we switch, in some cases, like GDP and production, very large events are very rare, and very small events are very common. You'll see this show up over and over again. And when we just plot in linear scale, often the relationships between the small values becomes obscured. So when we think about ratios, so doublings, in log scales, this becomes much easier to understand. So again, this figure should have all of the points highlighted, not just these 4. We'll see this in our exercise in a second. But if, I don't know, can you see those little dots? Sorry about the figures again. Those dots, I think this is much easier to see that there is a positive relationship between GDP and coffee production, because we're able to see the small differences between the small productions. Okay, so that's the main point here. Sometimes log scales are easier to understand, and we actually work in log scales pretty often, as you'll see when we start working with data like this in part 4. All right, any questions? Okay, y'all wanna get your hands on some data? So we're gonna work with this data set. I wanna show you a few things before we start talking about trivariate data, which is, I think, pretty fun. We don't do it a lot, but I think it's at least fun, so I wanted to include it. So in the exercise, you have coffee production and GDP. So the data I showed you here is we have this data set for 1999. Sorry, it's 2019. So this is the 2019 data. But my question for you is, did this relationship look different in 1980? So like 4 decades ago. Did we see the same pattern, the relationship between coffee production and GDP between these countries 40 years ago? So what we're going to do is actually work with the raw data and figure out the answer to this question. Okay, so the first thing we're going to do, so I have this data set printed out for you. This should say file path. When you load the data with file path, you should see a bunch of variables here. So we have country code. So this is the country itself. We have the year, which all of the data in this data set is in the same year. And then we have coffee production. So this is, how much production the country is making in billions of kilograms. And then we have GDP. We also have population, which we'll come to in a second. But my question for you, I would love you to visualize the relationship between these variables. So we're going to start by just simply plotting the relationship itself. So the relationship between GDP and coffee production. You know how to do this. We've worked with scatter plots. Let's maybe take a minute or two here to create the scatter plot. Let's put coffee production on the vertical axis and GDP on the horizontal axis like we did in the slides. And then we're going to create a scatter plot. You look at the scatter plot and you tell me whether it matches what's going on in 2019. Take about 2 minutes here. Yeah. The relationship between GDP and coffee production, just like we did in the slides, but here we're doing it for 1980. Okay, as you're working through this, someone want to walk me through what you did? How many of you were able to get a nice figure? Okay, a few. Someone want to walk me through what you did? Yeah, Pete?
I started with SNS.scatterplot.
So SNS.scatterplot.
Then with parentheses, I saved data equal GDP. I
Okay.
typed GDP.
Yeah.
80%.
Yeah, so you could use data is equal to GDP, or you can just skip the data is equal to part and just do GDP. Okay.
And then I did X is equal to GDP. And I did GDP was in quotes. And
Uh-huh.
the Y is coffee.
So coffee production, nice. And we'll run this. Okay, any questions here? So this is one of those cases where the data is, it is correctly visualized, but the answer to our question is a little more nuanced. We have a lot of data bunched up around 0. This is one of those classic problems with scaling. Anytime you see anything in prices, in general, you want to take a log, because you're going to have lots of things represented in numeric in dollars, clustered around small numbers. Very large dollar amounts are very unusual. The same thing is true with really anything that's measured at a country level, at a county level, or city level. These are all things that have this scaling property where we have a large number of small values and a very small number of large values. In those kinds of situations, it's often easier to use a log. So what we're going to do is take a log of these two variables. Okay, y'all are familiar with how to do this. So I have some code in the slides. The next thing we're going to do is create a scatter plot, much like I have in the slides, of the log relationships, a log scale on both axes. Yeah.
When you're saying like log, like obviously we've done like log and math.
Yeah.
Does it just like zoom into like the big pocket and making super small numbers, or what exactly like is it doing with the numbers?
Yeah. So let's see. So mathematically, what it does is it takes small differences and makes them look bigger, and then takes big differences and make them look smaller. So whenever there's sort of like exponential, a log is essentially the inverse of an exponential. And so what it's doing is just squishing the big numbers and spreading out the small numbers. Yeah. Okay, so I have some code in the slides for how to do this. We're going to take 2 minutes. I want you to, we have our scatter plot for the linear relationships, but I want you to create a log of both of the relationships, both of the variables, and then plot a scatter plot of those relationships. This is something I think almost a quarter of you will probably do on your final projects. This is a very common tool that we use. And I have some nice code in the slides to do this. And then your question is whether your scatter plot in 1980 looks different than this one. Once you have your scatter plot, turn to someone next to you, tell the person whether the relationship looks similar or whether it's different, and then we'll do this together on screen.
Do you mind going back to
Yeah. Yeah, that's okay. It's not the best thing to do, but it's not totally wrong. Or you could figure it out now. Okay. Respect the honesty.
wait, so and then you just run a normal scatter plot as explained it.
So what log?
Okay, someone want to walk me through what you did? Yeah.
I didn't write code, I just did the passionately.
Okay. So using Gemini, this is one of those cases where I think the actual doing of the thing is not so informative. And so using AI in these kinds of cases where you want to do something very generally pretty simple, but the actual remembering of the specific syntax is a little bit challenging. I think this is one of those cases where using AI is a pretty good tool.
So I just put in a few
Yeah.
log X, Y variables, and it loaded for me.
Okay. So sometimes it doesn't run here. Does it look like this?
Yeah.
So I'm just, instead of writing it all out, I'm just going to copy from the slides. And this is kind of a boring answer to the question, what did you do? But often this is the kind of thing we do. From memory, I can do this, but at the beginning of my career writing code, I wouldn't have remembered the specific nuance for how to do this. The reason I remember it is because I've written it so many times. So in some ways, using AI can get in the way of the remembering of the writing of it. But sometimes you just want to get to the code itself. And essentially all we're doing is just creating a new variable. So we're calling it log GDP. We're setting it equal to, this is numbers Python, and then we're just asking it to take a log of the variable that we put inside. And then we just do that for both variables, and we run that. Any questions here? This is not a Python class. I'm not teaching you all of the nuances of Python. We're using it as a tool to do what we want to do in the field. So what do we do next? What's the next thing?
Then SNS.scatterplot. GDP.
Yeah.
And then X equals log GP, Y equals log.
Nice. So we're going to use the log variables, the same axes. So we have GDP on the horizontal and production on the vertical. It's just we're taking the log values. Okay. Any questions here? So when we compare this to 2019, what do you all see?
It's a lot more spaced out. There's no
So the figure I have in the slides looks like this. And then the figure we have in our notebook looks like this. There's maybe a difference in the scaling of the horizontal axis. So maybe it looks like it's sort of more spread out. What does the relationship look like? So we've used different axes or different limits on the horizontal and vertical axis. So we here we see a lot of space between the data points. Here it's more clumped, partly because we have more data down, we have more space down here. But when I look at these two, I see generally positive relationships that don't look like they've changed that much. How do we interpret these axes? Like the scales? What we've done is transform a linear value into a log value and then plotted those log values. So what Python is doing is interpreting the log numbers on the horizontal and vertical axes, which are challenging to read. You'll have to, we often prefer doing it this way because when we run statistical models, we want to run the statistical models on the logged variables. But sometimes we want simpler visualizations. So what I've given you in the slides here, we're not going to talk through all of this in a lot of detail, but this is the sort of the simple step to construct a log-scaled scatter plot without doing the log transformations. This has Python do the log transformations behind the scenes when constructing the figures. And this often creates nicer visualizations. This is just creating the scatter plot like we did before. It's just we're asking for the scales to be log on the horizontal and vertical axes. So I'm just going to drop this in. And here we constructed the same data, but just with the log scales instead. Okay, and this is in scientific notation. All right. Is this enough about log scales? Yeah, I agree. These are useful things. We're not going to dwell on this too much, but this is the kind of thing we often have to deal with, and I want you to be thinking about when you're putting your data sets together. Often when data is clustered around zeros, we want to take a log so that we spread out the zero variation. All right, so that's enough about logs. Let me just walk you through some other ways of visualizing a third variable. So we just talked about 2 dimensions of data. So we have coffee production and GDP. But sometimes we want like a third variable. We don't do this very often, but we can visualize numerical variables in 3 dimensions on a 2-dimensional figure. So what we've done so far is encode the horizontal position as GDP and the Y position as coffee production. When we want a third variable, one thing we can do is change the size of the scatter points. This is sometimes called a bubble plot, which looks like this. And Seaborn has a really nice way of doing this very simply. All we say is give it a size parameter. So I'll show you this in a second. But this is pretty nice. Like, it shows a little bit more data than just the scatter plot, because sometimes like large countries also have large GDPs, and we want to know essentially whether all of these large production countries and GDP countries also have large populations. We can also annotate. So I've done a little bit of this. This is a little harder to do. The last thing we can do with these trivariate relationships is add color, which personally is one of my preferences for adding a third variable. So instead of using size, we can think about different colors, and then add a color scale. So here I have, instead of using size, I have colors. So the darker it is, the larger the population. And sometimes, depending on your eyesight, this might be easier to interpret. And this also has a standard way of doing this in Seaborn. You all are familiar with hue? We just add hue for population. And we'll do this in code in just a second. Okay, so these are nice. To summarize what we've just done, we talked about scatter plots to show relationships between two variables. We talked about log scales, where my slides were a little wonky. But the main idea is that when we have data that's clustered around small values and very spread out around large values, taking a log can give us a better picture of what's going on. And then we can also add a third numerical variable using a bubble chart or a continuous color scale. Okay, so I've also given you some code for how to encode the third variable. So in this case, we can use size to encode the population. So if I run over here and do this, this size parameter is just encoding the population size. And then I can tell it which sizes to range between using sizes. And then the last one is with hue. So as you'd expect, we've used hue before. If I want to encode using colors, so my third variable using colors, I can, I can use my scatter plot and then just add hue. So just say, so if I don't run with hue, it looks like this. And then if I add hue, it's equal to population. Then this will give me different colors based on the population size with the scatter plot. Which, I don't know. When we use three variables, sometimes this is helpful, sometimes it's not. Your mileage may vary. I think in general, 2 dimensions is about as good as we can get with numerical data, but sometimes this can be helpful. We can also put these things together, so we could have size and we can have both sizes and colors. But these are just some of the options, and I wanted to give them to you. As you're starting to think about your data sets, these can be useful summarization tools. But there's not a lot of deep theory here. Okay, any questions about this? Y'all look sleepy. Is that true? I understand. Do we want to talk about, I have like 3 slides here for time series, or do we want to take off early? We have to do this before the end of part 2. It'd be my preference to do this now. This is not exactly a democracy, but I like to know what you think. Should we do it now? Are you in? Okay, let's do this. So we've talked about cross-sectional data. yeah. Democracy when one person votes. So we've talked about cross-sectional relationships, but we can also use, we also can have 2 numerical variables, but in time series. So this is an example of similar kinds of things. We just talked about coffee production. Here I have 2 commodity prices. So this is clearly not cross-sectional, like we've just talked about. Many countries, 2 dimensions, so 2 measurements for every country at one point in time. Here I have 2 commodity prices. And my question is, how do these commodity prices relate to each other? This is through time. This is just markets. We have 1 measurement. When you look at this figure, what do you see? Yeah, Pete.
I didn't even notice the coffee line at first, so hidden on the bottom because the y-axis is scaled from 0 to 200, 400, 600.
Yeah.
And coffee's being measured in dollars per pound, which is probably like only a couple dollars per pound.
Okay.
It's really hard to see the difference between them.
So this is also not a good figure. This is a bad figure on purpose, unlike the other ones earlier. And the reason this is not very effective as a figure is because we can't actually see the variation in coffee per dollar. Anyone know what we can do to fix this problem? Yeah, bless you. Anyone know what we do to fix this problem? Yeah, Mairead?
Use the log scale on the y-axis.
Interesting. I don't think we might be able to use a log scale. I've never actually. It's a way of squishing large and small values, but I think in this case that's maybe not the most effective tool. In theory, I'm interested to check if that would work. I haven't actually tested that. The answer is not always logs. Yeah, incorrect. Yeah, 10 lecture points.
Can you just use a different range of the prices for the coffee?
Yeah.
Or the right side? Kind of like oil price.
This is, I'm sorry, remind me of your name one more time. Evan. So Evan's saying to construct a line plot, but with two separate axes. And then essentially we just overlay them on top of each other. So here what I've done, this is called a twin plot, where we have two different scales, one for each of the two commodity prices we're interested in. So vertical axis on one side is coffee price, which is a very different scale than oil price on the other. So if I were to ask you my original question again, are coffee prices and oil prices related? What was the answer? No. So Zach is saying no. Anyone have a different opinion? Yeah.
It could be roughly related.
Okay.
Just because it's not like the one that was like spiking on the far side or whatever. They're both like great.
Yeah, so they seem to maybe move in the same directions. Anyone want to represent the no camp? Like, that these are not related? Yeah.
Yeah, it's just a lot of the times coffee moves up and down when oil's not really like moving in the middle, oil moves down.
Yeah, so we have oil moving down, and
Toward the end, oil goes back up.
yeah, and then maybe down here. Yeah, so maybe they're not moving perfectly together, definitely. Yeah. How many of you think this is unclear? So I think you can make reasonable cases. To my eye, this looks like they're related, but I think, clearly they're not perfectly related. And I think looking at two lines moving together is not really that easy to tell. What are some other things we've done with time series that might make this easier? What if I gave you, I said, I'm going to check which quarter they move in the same direction, and I'm going to give that some shading, and then I'll check which quarters they don't move in the same direction, and I'll give that a different shading. What if it looks like this? So when they're moving in opposite directions, I've marked that in gray. So about half of the time it looks like they're moving in opposite directions. This is one use of background shading. I don't think this is really the final form for our figure, but this is one way of thinking about visualizing whether they're moving in the same direction or not. Anyone have other ideas about what we can do? What about this? But a scatter plot. So what I'm doing here is plotting coffee price on the horizontal axis. And then at that same time, not different countries, but different times, I'm plotting each one of those time periods, the price of oil and the price of coffee. And now, if I were to ask you whether coffee prices are positively or negatively related to each other with this figure, tell someone next to you, do you think this is positively or negatively or not related?
Coffee is definitely more expensive than brands. It's a little bit more
Who's your teacher for
All right, someone help me out here. Do we think coffee prices and oil prices are positively or negatively related? Hands up for positive. Hands up for negative. Hands up for no relationship. This to me looks like it's positive. We're going to get more formal about defining these kinds of relationships in part 4. But this is one of those effective uses of scatter plots, right? We have 2 dimensions of data at a bunch of different time periods. And this allows us to measure the relationship between those 2 dimensions of data through time. I'm going to caution you, as you're getting started with your projects, I don't encourage working on time series projects. They're very challenging. But this is one way of summarizing relationships through time using scatter plots. So we've talked about scatter plots in 3 contexts. One in panel data, both pre and post. We've talked about cross-sectional relationships. So when we have 2 variables across an index variable, so many countries and 2 dimensions, and then we plot a scatter plot. And then here we're plotting in a different way variation across time. So each point is representing a separate time period. So there are a couple more questions I was going to ask you. Maybe the last one here, does the price of oil determine the price of coffee? And the short answer is we are never going to be able to establish causation from a figure like this. It may be tempting to think when the price of oil goes up, it's more costly to supply and produce coffee. And so you may be thinking that there's a causal relationship between coffee and oil. And that may be true. But it may also be true that when coffee prices go up, people drink less coffee and are less productive at their oil fields. So there's at least one plausible way the arrow of causation goes the other direction. A figure like this doesn't tell us anything about the arrow of causality. It simply tells us that there's a relationship between the 2 variables. All right, so why don't we leave this here? There's a little bit more for time series, so if you have interest in doing this time series scatter plot, feel free to do that. It's in the exercise notebook. For today's exercise, just turn in one of the scatter plots we worked on, and then take a look at the homework. That should take you maybe 20 to 30 minutes. I think with the tools you have from class today, that should not take too long. So that's available for you. Let's see. Next week, we're going to start talking about categorical data and numerical data. So bivariate, but cross-type. Let's see. Stop by office hours tomorrow for your projects. Good luck. This should be fun. Yes. Yep, I will do that right now. Hey.
Question again.
Yes.
For part 1, for the last part, the image, the main variable of interest, I
submitted
the data file.
Okay.
Yeah. Do you want just any kind
I just
of
use a
visualization? Because I'm comparing NFL teams with years in the league and overall records to see if the length of existence correlates with the win percentage.
Yeah, very interesting.
Right? So, would that be like what I'm plotting for that visual, or?
So for part one, it's just summarizing a single variable.
Okay.
So in your case, you could plot like the distribution of win percentages.
Okay.
I guess, or you could plot the distribution of like length.
Okay. And then to open it as a CSV and collab.
Yeah.
So that I can just post the data
Yeah.
The file's not open.
But I was assuming that if I download this,
When it opened
it said
1.2,
save
how
it
would
as
I
the same
completely
name.
forget about
But I
it?
think the issue is
Yeah,
that
so this is
the
actually
way
not
your
straightforward.
drive
So
setup,
if
you have
you feel
to
like you're forgetting, it's because it's
the way
harder,
your drive
and we haven't
setup
actually
is
done
go
it.
through content,
If
then
you go
drive
to
code
the
out.
calculator,
So it's like
and
in my
then
No, I
drive,
just, I
process.
changed it. I got
Here I have a project template notebook,
Yeah, that's what I'm
which
saying. The
gives you a little bit of
collab
guidance
is
about
like
how
a
to do
folder
that.
in my drive. Like,
If
I
you
don't
get stuck,
have
what you
it-
can do is email me your data set, and I
I
can
just made a separate
put it on
Okay.
the website for you.
Yeah.
Okay.
Yeah,
But
I
this
think
is how
that's
you
the
would
issue with
go about doing
why
this
it's
for
not.
yourself.
Like this, the code,
So would
like this isn't a copy, but the code in this is like specific to
So essentially, what you do
Like
is
this-
you have to
that would make
mount
it-
Google Drive to the
because
notebook,
I don't have this,
essentially
like,
logging
I
in,
don't have this.
and then you would put
Like
the
my
data
drive
set
doesn't
in.
go from content to drive to.
So
like,
what
I
I
don't
did
know
here is
how-
create
I
a
don't know what
folder
format.
for
Right.
I think that's
different
just
project
like,
Zillow,
Okay.
and then I
You can
put
just
it
go to my
the
drive,
data set
that's the-
in the
that's the
Zillow
best
folder.
Okay.
Like my
And
drive
I would
is yeah,
sell.
my drive,
Okay.
and then
And
Alright.
then
But that's
down
what
here
that
you
top
would
one is.
put in
And
the
then
name
it's just
of the
go to
data
the
set.
folder.
That's
Okay.
it.
Okay. Great. All right. I'll try
yeah,
that.
see, but mine's
Okay,
in
this
you know.
notebook.
this is
I know, I
a
made
step
it,
that
if you just,
commonly gives
like-
people issues. So
Okay.
if you run into those issues,
Make a folder
you could spend 2 hours
Yeah.
trying to figure it out, or you could
Like, so what
uh,
So
save yourself some hassle.
Okay. If I need help, I'll stop by office hours tomorrow.
Yeah, sounds good.
But thank you.
Yes, you.
All right. So I just
So
having some trouble